Let's get started. Thanks for coming to my talk. Unfortunately, it's hard to see the audience. All right. This talk is all about EclipseStore, the new ultra-fast Java persistence for the cloud. So in this short talk, we will learn how to build the ultra-fastest database apps on the planet and how to build it. First of all, some information about myself. So my name is Markus Kett. I'm CEO and co-founder of MicroStream. We as a team are contributor to various open source projects. For instance, the Eclipse project, which is a visual development environment based on Eclipse. It's free and open source. We are the contributor to the EclipseStore project, which initially is called MicroStream. We also contributed to the project Helidon. We have contributed to the Micronaut project. I'm also founder of the GeeCON conference in Europe, in Germany, Europe, and editor-in-chief for the Java Pro magazine, which is a free Java magazine in Germany. This is the team behind the EclipseStore project, and we do this for 20 years. And so we are really, passionate Java programmers. We love Java, and our dream was always to make database development with Java faster and more comfortable. This is the reason why we worked for more than 8 years on improving the JBoss Hibernate tools and improving JPA development. And then we created the EclipseStore project, which is already open source and now becomes an Eclipse project. The project is already part of Helidon, so if you guys use Helidon already, by the way, who uses Helidon? Okay, you should definitely visit a Helidon talk. It's also integrated with Micronaut. We have a beautiful integration. Who of you uses Micronaut already? Okay, so many Spring users, obviously. All right. So, and the MicroStream project now is divided into 2 projects. So the MicroStream serializer becomes now the Eclipse serializer. And we will launch it hopefully this month, or at last done next month in May. And the MicroStream persistence becomes EclipseStore. EclipseStore also becomes a new standard for data storage in the cloud. So as I mentioned, it's already open source. It's available under EPL. And the big question is, why do we need a new persistence, especially for the cloud? So for instance, with microservices, we have some challenges. So there are some rules with microservices. For instance, each microservice should have its own database, and the database you use for the microservice should fit to the specific domain of this microservice. And there are so many different use cases. For instance, machine data or more complex graph data. So the question is, do you want to use various databases for your microservices? So this can be a little bit challenging. So there is a lot of effort for testing, development, and DevOps stuff. So, and we also have challenges with serverless functions and traditional databases because of the stateful database connections, and so various challenges with microservices. But of course, there are also challenges in general with traditional Java persistence. Java is great. So we have the perfect programming language. It's object-oriented, type-safe. So, and everything is fine when we're in a Java world. But as soon as we have to store data, we have to leave this object-oriented way, and then we have to use a database. And a database works fundamentally different from Java. So in Java, we have the Java object model, and with a traditional database, we have tables and columns. And it's not possible from a technical perspective to store objects in a table. So we have a problem here. It's called impedance mismatch, and we have various impedance mismatches here to solve this problem. What's about the NoSQL databases? The NoSQL databases provide completely new data structure, but they are also incompatible with the Java object model. For instance, JSON or XML or graph. Graph databases, they introduce their own graph model, so they are also incompatible with the Java object model. We have the same problem here as well. So to solve this problem, we need a kind like mapping. So with relational databases, we need an object relational mapping between the app and the database. And it's the same with the NoSQL databases. We need a data conversion through every single read and write. And this is very expensive and slows down our applications. To accelerate database applications, we are used to add a cache. But this, on the other hand, increases the complexity of our systems, and only for storing some data. If you have distributed applications, then it's a little bit more complex. Because when we change some data on one node, then this node and the database are in sync. But all other instances are not in sync with the database, so this might be a problem. To solve this problem, we are used to use a cache in between the application and the database. And so we are used to use a distributed cache. You can see the complexity increases more and more. To manage the load on the database server, we are used to use a database cluster. So we have in total 3 clusters to manage. And the question is, so we are used to build such systems, right? The question is, can we do it better or more simple? And we believe we can do better with Java, with core Java, because Java is extremely powerful and convenient to use. Why? It's because the Java virtual machine is incredibly fast. The JIT compiler will optimize your app that you get out an app that is as fast as a C program. Great news, which means everything that is executed in memory with Java is super fast, highly optimized through runtime. What is the best data structure? Key value, JSON, a graph? With the Java object model, we have the perfect data structure. We have an object graph. We can build object graphs. And we can use all Java types. We can use collections. We can just store a simple list in memory for sensor data. We can also create a high complex object graph similar to a graph database. We have this in Java already. What's about searching and filtering? With the Java Streams API, we can search and filter in memory in microseconds. When we talk about query time of a database, we talk about milliseconds. This is 1,000x faster when we use Java Streams API. Here are some numbers. Everything that is executed in the memory, we talk about microseconds. So, and accessing to a hard disk, for instance, takes mostly milliseconds, 1000x faster than we do it in Java in memory. What's about costs? When we use a database as a service in the cloud, let's say we need 250 gigabyte PostgreSQL. It depends on the machine size, but if you use 4 CPU, 8 gigabyte or 16 gigabyte memory, it costs around $8,000 per year. We talk about a single node to share the load, get high availability. We need replication. Let's say we use 3 nodes. It costs $26,000 per year. The more nodes you will use, the more expensive it will be. So in comparison, the cloud binary blob storage like AWS S3 or Azure Cloud Blob Store, in comparison, costs only $70 per year. Incredible cheaper. And now the question is, can we combine all of these advantages? And with EclipseStore, we follow the system prevalence pattern, which is a simple architectural pattern. It's known since decades. The functional principle is simple. So EclipseStore is now a Java native micropersistence layer that runs similar to Hibernate within your Java application or your microservice. It enables you to store any kind of object graph, any complexity, any size, persistently on disk into any storage. And vice versa, it allows you to load single subgraphs and object references with lazy loading into the memory and restore your objects in memory by just calling some methods. That's what EclipseStore actually does. It's a small, tiny Java library you can download via Maven, and of course the code is available on GitHub. And the project will be available under this domain, eclipsestore.io, soon. Currently, you find the project on microstream.1. It's already under EPL. So what we changed? Let's have a look under the database, so behind the scenes. So actually, we have a database management system, a database server. There we have storage, we have memory, we have perhaps business logic and the database management system. On the JVM side, we have mostly Hibernate, a local cache. So now with EclipseStore, we replace Hibernate, for instance. We use the object graph in memory as an in-memory database. We query this with Java Streams API. The data are already in memory, which means we don't need a cache anymore. We can skip the cache. Because of everything is already in memory and we search and filter in memory, we don't need a database server anymore. We don't need a database management system because everything is managed by the application logic. The only thing we keep is storage. Just store binary data on disk. And this is actually the functional principle. We serialize the data persistently on disk by using the new Eclipse serializer. As a storage, we can use everything that is able to store binaries. So all databases actually are able to store binaries, of course. So you can use plain files, a common database. We recommend to use a blob store like S3 because it's super cheap. In terms of performance, let's have a look on the performance. Come on. So here is a small performance demo. And it shows here are 2 applications running in parallel. It's a bookstore demo. You also can download via Maven. Its code is on GitHub. 2 applications are running. One is built with Hibernate and cache. It's a hot cache, by the way, and we have a 250 gigabyte PostgreSQL database. The other application is built with MicroStream, which is now EclipseStore. And here you can see we compare traditional JPA queries with Streams API, and every single query is executed sometimes only 100 times faster, sometimes up to 1,000 times or even faster with pure Java, with Java Streams API. So in most cases, you will beat a conventional JPA query more than 100x or 1,000x. So this is really incredible fast. It's cheap because we can use blob storages like S3. What's about replication? So we also can not only use EclipseStore on a single JVM, which is built for a single JVM, so you can use it also for monolithic applications. Let's have a look on the architecture when we use it with distributed apps or microservices. So we replace the application cluster, so with EclipseStore cluster, distributed EclipseStore app. We have all data in memory. We are now able to replicate the object graph through hundreds or even thousands of JVMs, which means data are already in memory. We don't need the we don't need the distributed cache anymore. Because we store data in AWS S3, we don't need a database cluster anymore, so we can skip the database cluster, just use S3 for $70 per year. We can remove the distributed cache, and we get out a simple architecture that is high performant, saves you a lot of cost of infrastructure, and is super to maintain, super easy to maintain. In comparison, again, we can reduce the complexity of our applications tremendously. There are 2 ways to run an EclipseStore cluster. You can replicate your JVMs directly and execute queries with Java Streams API, but we also can put it in a layer between the application nodes and the storage by adding microservices or distributed application nodes, and we put the EclipseStore cluster in between and query the cluster by using REST or GraphQL. Then you can build your application nodes or microservices even with other programming languages. But I guess this is not so important for this conference, right? All right. So again, your benefits are simplicity. It's super easy to use because you just use your classes as they are, just POJOs. No more building your application code around the database. No more mappings, no more data conversion. Build your object graph freely. Use all Java types, use collections. You can create your own index. You can do whatever you like. You can use Lucene and EclipseStore will be able to store it. No interfaces to implement, no serialize able to implement. There are no superclasses, nothing, so no annotations, super simple to use, just an API. High performance, so we talk about microsecond query times and cost savings, in the cloud especially. So we save lots of machine power, CPU consumption, and cloud storage costs. Of course, there are also trade-offs and challenges, because if you're not a Java developer, you're out. Leave the room, run away. So DBAs are out. You have to care for concurrency. There are really also some trade-offs. So we are not the database management system, but with Java knowledge, you can use it very easily. So if you want to check this out, MicroStream serializer becomes Eclipse serializer, MicroStream persistent becomes EclipseStore, and EclipseStore becomes a new standard. So now we run out of time. Last but not least, I have a gift for you, and this is very funny because I'm from Germany, and in German, gift means poison. But don't be afraid. So you can, if you're interested in EclipseStore, you can now enroll for free courses, and if you register for our raffle at our booth, then you can also enroll for further courses, online courses about Quarkus, Spring Boot, Micronaut, Helidon, and everything for free of charge. So take a picture, come to our booth, and check it out, and give us feedback to this project. If you have any questions, yeah, you can find me at our booth. Thank you so much. Thanks for joining, and have a great day at GeeCON. Thanks.